Okay, so hopefully by now you guys have listened to my little pep talk on this stuff we're doing and about next year, and got something out of the video from Khan Academy. And you're going to notice a lot of overlap between that video and my video, which is going to get us started on our lesson that I'm going to do a lot of problems on because it's really quite difficult. So an angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive axis. The ray on the x-axis is called the initial side, and I'll label that in pink. The other ray is called the terminal side, which I will label in green. Counterclockwise rotations result in positive angle measures. So this angle right here, since it is going in the counterclockwise direction, is going to be positive. And look, it looks like it would be about 135 degrees because it's about halfway in between 90 and 180. Clockwise rotations result in negative angle measures. So that would be this angle here, written negatively, would be what? Does anybody have a guess? This could be a candy question. Well, that would be 360 take away 135, which is going to be, what, 225 degrees? Negative 225 degrees, actually, because it is going in the clockwise direction. And one full revolution, of course, is 360 degrees. Number one, drawing angle. Sketch an angle with the given measure in standard position. So 75 degrees, well, that's positive, so it's going to come up in this direction. We know that this is 90, so that would probably go to about here. Negative 160 is going to go in this direction. So it's going, we're getting to negative 90. And if we get all the way this far, we're to negative 180. So negative 160 would probably be about like that. 430 would be positive. So that part of it right there is 360. But then we need to keep going up in that direction. So 430 minus 360 is 70. So we would need to come up here. Basically, it's going to look about like this angle here, but 5 degrees less. So let's just go ahead and draw it about like that. Okay, and that will be my 430. Okay, here we go. This really gets into what Saul was talking about in the con video. So we have a radian is a unit of angle measure based on arc length. 1 radian is defined as the measure of a measure of the angle formed when the radius is equivalent to the length of the intercepted arc. Recall that the circumference of a circle is 2 pi r. Therefore, 360 and 180 are. Some of you might have picked that up in the video that he was talking about. So 1 radian basically is when this length here is equivalent to the length of the radius. And then we also talked about, as far as arc length goes, if we want the entire arc length of a circle, that is the formula for circumference, which is 2 pi r. So 2 pi radians. So we know that the entire 360 circle is 2 pi radians, which is this, which is whatever the radius is. So the radius, no matter how big or small, when you multiply it by 2 pi, is going to give you the circumference of the circle, of course. And if 2 pi is 360, well then 180 is going to be half of that, and half of 2 pi is pi. Okay, so if we want to convert between degrees and radians, we have 2 different formulas that are given here. So we need to convert each one from degrees into radians. So I'll do a couple of each. And I ask that you do not work ahead on this, okay? So I want to start with 6, which will actually be kind of the toughest one. So picture negative 220, okay? And let's just talk about negative 220 before we actually do the algebra. So negative 220 is moving in the clockwise direction. There's negative 180. And then basically, it's going to come up another 40 degrees to about here, okay? So, if we were estimating this, because we want to start making sense of this, not just getting right answers, but making sense of what it means. Well, I would know that 180 here is pi, or negative pi, in this example. And if I were to continue up, I know that 2 pi exists over here. So I'm kind of like, okay, well, if I were to get this far to here, what would I have there, do you guys think? Well, that'd be like 1.5 pi, right? Or 3 over 2 pi. So I'm kind of somewhere in between 3 over 2 pi and pi. Or in decimals, I'm somewhere in between 1 and 1.5 radians. Let's check it out. So we're going to go over here and we're going to plug in the algebra. So we're going to go negative 220, and we're following this one right here, converting degrees to radians. Negative 220 times, and then over here we have pi radians, or pi, over 180. And when we multiply that, we get negative 220 pi, negative 220 pi over 180, which is equal to, we don't get decimals with this, we reduce to negative 11 pi over 9. Now think about that, how that compares to our estimate. We estimated that it would be somewhere in between 1.5 and 1. And sure enough, this fraction is right in between, 1.5 would be like negative 13.5 over 9, right? So we're somewhere in between, and our estimate was correct. So 4 and 5 will be part of your assignment today. Don't do them now. Let's go ahead and do the other way. So let's go these ones, and let's work them into degrees. So let's start with 8, okay? We have negative 5 pi over 36. So let's go over here to our circle and think about what that would be and what that would look like. So we know that if I'm going in this direction here in the negative, that this right here is 1/2 pi. Because this full one, or negative 1/2 pi, and this full one is negative pi. So if that's a half, a sixth, a negative sixth, is going to be something real small like that, right? Let's find out. So I'm going to go negative. We're going to do what our formula says. We're following this one here this time. So I'm going to go negative 5 pi over 36 times 180 over pi, to go kind of back and forth in between the two. So when I do that, I'm going to get, let's see, negative 5 pi times 180 is going to be negative 900 pi over 36 pi. And if I go negative 900 divided by 36, my pi's cancel because pi divided by pi is pi. And I figure out that this goes in negative 25 times. So as we guessed, this angle right here is negative 25 degrees. That leaves you with enough information to get through problems 1 through 9. Okay, going to the next page. Angles in standard position with the same terminal side are called coterminal angles. Give two coterminal angles for each given angle, one that's positive and one that is negative. Okay, so with this one, we have 65 degrees. So I always like to picture these things so they have meaning, okay? So if that's 65 degrees, what are two other ways to express that? One positive and one that is negative. So our negative one is going to go like this. And we would calculate that by going 65 degrees, take away 360, which is going to be negative 295. And then in a separate color, I'm going to have my other one, which is going to be 65 degrees, and then we need to go, okay, here, and then all the way back to here would be what? Well, that would be 65 plus 360. And when we do that, we're going to get 425 degrees. So when I was first kind of doing this, because it has been a while since I've done it, I was thinking, oh, okay, well, this section is easy. It's just 65 minus 360 and 65 plus 360. And then I have my one positive and I have my one negative. Well, when we run into a problem with that is like on the next one, okay? So if I, right here, if I go 540 plus 360 and 540 minus 360, I get two positive numbers. And that's not what the instructions called for. The instructions called for a positive one and a negative one. So let's start out the same. Let's go 540 minus 360. Now please note, negative 540 minus 360 and 540 plus 360 are both coterminal angles to 540. However, one of them is not positive and one of them is not negative. All right, so this one is going to be 180 degrees. Okay, so 180 degrees is the same as 540 degrees in this situation. So in order to get my negative one, knowing that these two are the same, what do you think I'm going to do? Well, I'm going to take 180 degrees, which is the same thing as 540 degrees, and I'm going to take away 360, which is going to dip into the negative and give me negative 180 degrees. Okay, so that's how those ones are going to work. So when it's above 360, like this, and one has to be positive and one has to be negative, you have some kind of thinking to do. All right, so you have to be able to spot above 360 and below 360 in radians. So when I go to do 12 and 13, I'm going to check to see if I can do them real quick, like number 10, which is just 65 minus 360, 65 plus 360. But I need to know if those are greater than an entire circle or less. And basically, if they are greater than 2 pi, okay, so if I have something like, let's say 30 pi over 12 or something, okay, that's greater than 360 degrees because it's greater than 2 pi. Now, here, 13 pi over 180, that is not greater than 2 pi. And 14 pi over 9 is not greater than 360. So these ones are going to be easy. So we can just go, in this case, just like we did in 10, we can go 13 pi over 18. And what are we going to take away and what are we going to add? Well, we're going to take away 360, which in radian land is negative 2 pi. And we're going to, well, maybe we should just do that before we get too far ahead of ourselves here. So how do we express 2 pi in 18ths? Well, we have to go ahead and make it, what, 36 pi over 18? Negative 23 pi 18ths. And then my other one is going to be 13 pi over 18 plus 36 pi over 18. And that is 49 pi over 18. I'm going to let you do 13 on your own later. Let's move on. For any angle theta in standard form, the reference angle is the positive acute angle formed by the terminal side in the x-axis. Sketch and find the reference angle for each angle. Okay, we can do that. So let's picture 225 degrees. It's positive, so let's picture it, okay? There's 180. Here's 270. So this one is kind of like in between, right? So here is our angle of 225 degrees. Now our reference angle, remember, is compared to the horizontal line formed by the x-axis. So our reference angle is this, okay? So just so you guys know, if this is my angle, that's my reference angle. If this is my angle, that's my reference angle. If that's my angle, that's my reference angle, always compared to the x-axis. So there's 225 degrees. So all you need to do is calculate that purple angle. And we know that this is 180 and this is 225. So all we have to do for this one is just go 225 take away 180. And that's going to tell us that that angle right there is 45 degrees. Let's do, I think that you can get negative 310. Okay, remember, I'll start it for you. So negative 310, there's negative 270. Here's negative 310. You're calculating that angle. You can do that. Okay. Now, what about 2 pi over 3? A little bit harder, right? A lot harder, actually. Okay. So when you're doing these and you're not super familiar with radians yet, I would convert 2 degrees and solve. Okay. So run it through the formula above and get 2 pi over 3. Which is in the positive direction, so it's going to be heading this way, right? And we know that this is half pi, and we know that this is full pi. So 2/3 pi, it's going to be somewhere in there, and you're going to be solving for that angle right there, okay? You can do it. All right, more new stuff, trig functions. Let theta be an angle in standard form, and Pxy be a point on the terminal side of theta. The distance from P to the origin, r, can be found using the formula, the Pythagorean theorem, which in this case is x squared plus y squared equals r squared. So this is real easy. You guys can figure that out. So the sine of, remember, it's that on the terminal side, so it's over here. Okay, so the angle that we're talking about is that purple one I have marked. So sine would be opposite over hypotenuse. Okay, and then cosecant would be, hypotenuse over opposite. Those will go real quick. 17, if 5, negative 2 is a point on the terminal side of theta in standard form, find the exact values of the trigonometric functions of theta. So over here, we got the point 5, negative 2. Go ahead and picture it like right there, okay? And here is this coming down through that point, and this is the point 5, negative 2, making this distance right here, negative 2. And it would make this distance right here 5. So the first thing that we need to do is we need to figure out the distance of the hypotenuse. So 2 squared plus 5 squared is 29. So basically the hypotenuse is the square root of 29. It's getting a little jumbled in here, but we can write this as the square root of 29. Oh, that's the work we're supposed to show in here. So anyway, there you go. So x, if you're looking at our top example, remember r was the hypotenuse. So r is the square root of 29, and x is 5, and y is negative 2. I just have to do what you did above, all right? But, of course, it's a little bit trickier with trickier numbers. So the sine of this situation is going to be the opposite, negative 2, over the hypotenuse, which is the square root of 29. What's wrong with the way that I have that written? Let's see if anyone remembers. Can't have a radical in the denominator. So the sine of theta in this case is negative 2 times the square root of 29 over 29. Okay? You'll be able to set up the rest of the ratios, I'm sure. Okay, now you're going to get into a bunch of practice because, like we said, this is difficult. You're going to convert. You got to practice that a lot, okay? A lot. And then we're going to get down to, let me see here. We're going to get down to this section here, which I'm going to see if you guys can kind of handle on your own a little bit more. I'll probably end up calling the class together to do some of these, and then that's tomorrow. So again, remember we have a rule about the whole detention thing. Don't work on till tomorrow, even if it looks intriguing and you might learn more. Fight the temptation, okay? And I know the temptation is only there for some of you guys, but don't move on to it. But basically here you're spotting the coterminal angles, which are ones, remember, that are one positive and one negative. That's what we did in the beginning. And then the reference angle, which is this one. And some of them are going to have degrees, and then some of them are going to have radians. Do you guys remember what I said to do when they're in radians? Yes, we're going to convert them to degrees and then solve. All right, guys, I hope between my video, the Khan Academy video, and especially each other, you're really going to have to work together today to get through this. And my help, that by the end of the period, we will all be getting this very difficult lesson.